In this video, I show you a neat and concise way of dealing with algebraic expressions where directed numbers are involved. But first, let's just clarify a couple of things. These symbols here, this one is sometimes used, isn't it, for addition, as in 7 add 5. Sometimes it's used to indicate the sign of a number, as in positive 3 subtract positive 4. And sometimes the word plus is used for this or this, and because it has a dual meaning, I tend to try not to use it. Likewise, this symbol, sometimes it's used for the operation subtraction, as in 7 take 5. Sometimes it's used to indicate the sign of a number, as in -2 in 3 add -2. And likewise, there's the word minus, which sometimes means subtraction, sometimes means negative. So I tend to try not to use that. So in summary, these symbols, sometimes they're for an operation, sometimes they're to indicate the sign of a number. So before we go on, you must be confident with adding, subtracting, multiplying, dividing directed numbers. If you're not, maybe you want to stop the video and address that first. Or if you want to go on, have your calculator ready so you can do any adding, subtracting, multiplying, and dividing to check my working. Now, another little idea. Let's think about this. 7 take 3. Obviously, the answer is 4. Now, if we think about 7 add -3, 7 positives, because remember, if there's no sign associated with the number, it means it's positive. 7 positives and 3 negatives is in excess of positives of 4. So the answer to that also is 4. So these two things yield the same result, which tells us to subtract a number is the same as adding its opposite. The opposite to 3 is -3. To subtract a number is the same as adding its opposite. File that little idea away. Likewise, if you think about 5 plus -3, 5 positives and 3 negatives, excess of positives of 2, that's the correct answer. And obviously the correct answer to 5 take 3 is 2. These two things are equivalent. That tells us to add a number is the same as subtracting its opposite. The opposite to -3 is positive 3. So we can look at it this way as well. To add a number is the same as subtracting its opposite. This one we don't use so much, but let's file it away and use it in the pages coming up. Now, when teachers and textbooks explain this work, we sometimes get loose about the meaning of these symbols as to whether they're an operation or a sign. Now we do that for a reason, because it makes it much easier to deal with these things. I'll show you that in this example. If we want to simplify this, we write the question down and then we gather the like terms. There's a 5x here and a subtract 7x, so let's put those together. And I'm looking at the sign in front of the term here. Subtract, or the operation, subtract, and then we have subtract 3 and subtract 5. Now our like terms are together. Now this is where we get a bit loose. We say 5 add -7 is -2x. That's fair enough. And we say -3 and -5. 3 negatives and 5 negatives is 8 negatives. So this is the same as -8, or we just say subtract 8. So there is the answer. Now I've been rather loose there in the way that I've used subtract or the sign, negative sign. Let's do it strictly and see what you have to do. It's much more work involved. So write the expression down again, collect our like terms, and now what you have to do is say, well, this is equal to 5x. Subtract 7 is the same as adding its opposite, which is -7. To subtract 3 is the same as adding its opposite, which is -3. To subtract 5 is the same as adding its opposite, which is -5. Now we can collect the like terms and say that 5 add -7 is -2, so it's -2x. -3 plus -5 is -8. So this is the same as adding -8. And then we use the idea that to add a number is the same as subtracting its opposite. So instead of adding -8, we'll subtract 8. And you see that we have the same answer. A lot more involved when we're strict, isn't it? So we tend not to do it that way.